Hi, my name is Byron E. I'm a math and physics tutor over on Chegg.com, and today I'm going to be talking about the Cartesian and polar coordinate systems. Now this is a topic with real-world implications that really help simplify a lot of problems. So here you can see we have a green point expressed in polar coordinates and a red point expressed in Cartesian coordinates. By the end of this lesson, you'll be able to write both of these points in both coordinate systems. So let's go ahead and get started, starting with the green point. So as you can see here, in polar coordinates, points are expressed in terms of r, which is the distance from the origin, and theta, which is the angle with respect to the positive x-axis. Now over here I've written the formulas for the conversions. These are the formulas you want to put in your notebook and study before your exams and stuff. So if we go ahead and get started, we can plug in some of these numbers. So let's start with x. Say x equals 5, which is our r, cosine of 3 pi over 4. Now this angle is expressed in radians. You'll want to be careful. If you're given the angle in degrees, you'll have to either convert or simply just change the setting on your calculator. So if you plug these into your calculator, you'll come up with an x of about minus 3.5. Now this is rounded, so you'll have to be careful about accuracy of your calculations. Now let's do the same thing for y. We have y equals 5 times sine of the same angle, 3 pi over 4. Plug that into your calculator, and you'll get y equals, again, about 3.5. This time it's positive. You can see that on the graph. So that's it. And we can go plug that in to our plot over here. We have that this point, expressed in Cartesian coordinates, is negative 3.5, positive 3.5. So now, let's get started on the other conversion. So Cartesian coordinates, as you know, is expressed in terms of x and y, and we're solving for r and theta. So this can be simplified if we just think of this as a right triangle. So I'll make it bigger down here. We have a right triangle, and what do we know? We know the x and y, which are the lengths of these sides. So the length of this side is 4, the length of this side is 3. So what is r in this case? Well, r is simply our hypotenuse of our triangle. So let's go ahead and solve for that first. So if you know the two sides of one triangle, you can solve for the other using the Pythagorean Theorem, which is a squared equals b squared plus c squared. So in this case, we know the b and c. So let's go ahead and write this in terms of r. R squared equals 4 squared plus 3 squared. So we can throw our square root sign over on the other side and go ahead and square these. So we have 16 plus 9. So that is the square root of 25, which as we all know, is 5. So in this case, our r equals 5. Now how about theta? Theta is going to be this angle here, theta. So if we remember our trigonometry, we know that the tangent of theta is equal to the opposite over adjacent. Remember the SOHCAHTOA rule. So tangent theta is the opposite, which is 3, over adjacent, which is 4. So if we're solving for theta, we just have to take the tangent inverse of 3 over 4. So if you plug that into your calculator, you get negative 0.64 radians, or if you like, negative 36.87 degrees. And these numbers are rounded. So that's it. Let's just go plug those in. We had an r of 5 and a theta of negative 0.64. And that's it. So just to review, the formulas you want to use: x equals r cosine theta, y equals r sine theta. This one, r equals square root x squared plus y squared, and theta is the tangent inverse of y over x. So if you'd like to put those in your notebook too, that's fine. I kind of recommend just sort of remembering the logic behind the derivation, and you can easily just draw the triangle yourself each time. That way it's kind of longer term memory sort of thing. So that was my lesson on Cartesian and polar coordinate systems. I hope you found it useful. Thank you for watching. If you have any questions in the future, feel free to go to this URL and message me directly, or just speak to any one of the great tutors on Chegg.com. Thank you.